Good day. Our next lesson is number series. So before, we talked about number sequences. And now we'll talk about number series. Ang plural ng series ay series pa din. And we'll start with the arithmetic series. Let's start by defining what a number series is. So a number series is just the sum of all the terms of a number sequence. So in an arithmetic series, this would be if you have an arithmetic sequence, tapos add natin lahat ng terms niya. So 1 plus 2 plus 3 plus 4 and so on. And a geometric series would be a geometric sequence na i-add natin yung lahat ng terms. So for example, pwedeng 1 plus 1 half plus 1 fourth plus 1 eighth and so on. Notice that in this case, our common ratio is 1 half. Minumultiply natin ng 1 half yung bawat term to get to the next term. Then add natin sila lahat. Harmonic series, ganoon din, add din natin yung terms ng isang harmonic sequence. And the concept of series sa math, medyo madami siyang applications, especially as you go higher up. So ito lang yung basic introduction natin sa series, but later on, you might encounter some very important series such as the Taylor series na ina-approximate yung isang function based sa kanyang derivatives tsaka sa isang binomial. So this would be something that's waiting for you excitedly sa higher math lessons niyo. So let's proceed sa arithmetic series. First thing that we need to point out is that pag i-add natin lahat ng terms sa isang infinite arithmetic sequence, palaging pupunta tayo sa either infinity or sa negative infinity. Kung ang common difference mo ay positive, pag in-add mo siya all the way to infinity, kahit kano pa kaliit yung common difference mo, aabot yan ng positive infinity. At the same time, kung negative yung common difference mo, kahit kano kalaki yung starting point mo, kahit kano kaliit yung common difference mo, kung negative yan, pupunta ka sa negative infinity. So it might be that the arithmetic series as a whole, hindi siya magiging masyadong relevant unless we talk about the partial sum of an infinite arithmetic series. So hindi natin i-add all the terms all the way to infinity. Kukunin lang natin yung first n terms. So our focus will be on the partial sum of an infinite arithmetic series, and this will be the sum of the first n terms. Ayan, kaya natin siyang i-compute. Now, there's an apocryphal story. Apocryphal meaning hindi natin alam kung totoo talaga siya, tapos kinukwento na lang siya paulit-ulit over time about the young mathematician na si Carl Friedrich Gauss, na supposedly when he was 7 years old, medyo magulo siyang bata, dahil magaling siya sa math, hindi na siya nakikinig sa lessons niya sa classroom. So, yung teacher daw, para matigilan siya at para ma-keep siya na busy, binigyan siya ng task na, Carl, you have to add the numbers from 1 to 100. Ano yung sum? And this is probably not a true story, no? Pero kunyari na lang na kinukwento para i-bolster yung myth ni Carl Friedrich Gauss. So, iniisip ni teacher, aabutin siya like siguro the whole class period to add from 1 to 100. Tapos it only took him like less than a minute, tapos sinabi niya sagot. Tapos nagulat yung teacher kung paano niya ginawa yun, tapos in-explain niya. And supposedly, nung binigay ni Gauss yung explanation, na-explain niya exactly kung paano natin i-derive yung partial sum ng isang arithmetic series. Let's go through that supposed process na ginawa ni Carl Friedrich Gauss. So let's start by listing down the terms in the arithmetic sequence all the way to 100. So finite arithmetic sequence kasi we're only looking at the first 100 terms. If we match up the first and the last terms, the second to the last and the second term, the third term and the third to the last term, the fourth term and the fourth to the last term, and so on, until umabot tayo dun sa gitna na pairing. Ano yung magiging sum ng bawat pair na yan? So, as you could observe, they all add up to 101. Tapos, ilang pairs yung meron tayo sa setup na to? Since each pair adds up to 101, and we have a certain number of pairs na each adding up to 101, if we just multiply yung 101 with the number of pairs that we have, then we'll get yung sum from 1 to 100. So, how many pairs do we have? And that's just 100. Divided by 2 or 50 pairs. And 101 times 50 is 5,050. So supposedly, ito yung process na ginawa ni Gauss para makuha yung 1 plus 2 plus 3 plus 4 all the way to 100 na supposedly ina-expect ng teacher abutin ng buong class period Pero nagawa niya in maybe less time that it took for us to solve for it. So let's just declare our final answer, the summation from I equals 1 to 100 of I. This is equal to 5,050. And this is our final answer. So familiar naman tayo sa summation notation, I presume. Now to generalize, a formula for all partial sums ng first n terms ng arithmetic sequence, let's list down the first n terms of an arithmetic sequence. So we have a sub 1 plus a sub 2 plus a sub 3 plus and so on, plus a sub n minus 2, ito yung third to the last term. Ito yung second to the last, ito yung third to the last term, a sub n minus 1 plus a sub n. Ito yung first n terms ng arithmetic sequence. And then I will rewrite each term to reflect na para umabot tayong second term, nag-add tayo ng common difference. To umabot ng third term, nag-add tayo ng common difference 2 times. And so on. To get to the second to the last term, this is nag-add tayo ng n minus 2 minus 1 times ng common difference sa first term. The second to the last term is a sub 1 plus n minus 2 times d. And the last term is the first term plus n minus 1 times natin i-add yung common difference. So, I hope we follow this. We follow the same process na ginawa natin kanina. We match up the first and last terms, the second and the second to the last terms, the third and the third to the last terms. And we observe that the sum of the first and the last term, this would be equal to 2a sub 1 plus n minus 1 times d. If we compare this with the sum of the second and the second to the last term, so a sub 1 plus d plus a sub 1 plus n minus 2 times d. So may a sub 1 tsaka a sub 1. Add natin sila. We get 2a sub 1. And meron tayong n minus 2 na d. Add natin sa isa pang d. E that's n minus 1d. So it's exactly the same as the sum of the first and the last term. And you'll observe that this would follow for all the remaining pairings. Ng third, third to the last, fourth, fourth to the last, and so on. And how many pairs do we have? We'll have n over 2 pairs pa rin. So the partial sum of this arithmetic sequence, or the first n terms of this arithmetic sequence, is yung sum ng bawat pair given by 2a sub 1 plus n minus 1d times number of pairs, which is n over 2. But we should keep in mind na itong sum na to, ito din yung sum ng first and last term multiplied by the number of pairs. Now, baka sabihin nyo, paano kung hindi naman even yung number of terms in our arithmetic sequence? Like, paano kung first 9? So, hindi tayo makabuo ng pairs. May isang sosobra. Okay lang yun. Then that term, yung gitna, kalahating pair siya. So, ma-accommodate pa rin natin siya dun sa formula. So, let's summarize our formulas. The partial sum of the first n terms of an arithmetic sequence is given by these two formulas. The first one, yung given lang sa atin yung first term tsaka yung common difference, which is 2a sub 1 plus n minus 1 times d times the number of pairs n over 2. But if you know the first and the last terms, then the partial sum will be a plus 1 plus a sub n times the number of pairs n over 2. Let's take a look at an example, but what I want you to do is to pause this and try to solve this on your own. Okay, so let's compare your answers with my answers. So we're looking for the sum of the first 30 terms, s sub 30. Our first term is equal to negative 15, and the common difference by inspection is positive 2. The sum of the first 30 terms using our formula will be 2 times the first term plus n minus 1, or 30 minus 1 times the common difference times the number of pairs. So the first term is negative 15, n is 30, so this will be 30 minus 1. The common difference is 2, and ilang pairs meron tayo? We have 30 over 2. Simplifying this expression, we'll have negative 30 plus 29 times 2, 58 times 15, and our final sum is 420. So the sum of the first 30 terms of this arithmetic sequence is 420. Before we solve our second example, again, I want you to pause this and try to answer this on your own. The sum of the first 15 terms of an arithmetic sequence is 270. We're only given the 13th term, 33, and we're supposed to find yung common difference. So pause it. Okay, let's compare our answers. So we're given that the s sub 15, the sum of the first 15 terms is 270, and that the 13th term is 33. Now, alam natin yung formula ng first 15 terms na sum is the first and the last term times the number of pairs. Pero hindi natin alam either the first or the last term. So, isipin natin, ano ba yung kapartner ni 13? 13 is the third to the last term. So, 13, 14, 15. So, ang kapartner ng third to the last term is the third term para makabuo pa rin ng same sum ng first and last terms. So, this is also equal to a sub 3 plus a sub 13 times the number of pairs, 15 over 2. So, substituting the values that we know, 270 is equal to the third term plus the 13th term plus 15 over 2, should be 540 over 15. This is equal to a sub 3 plus 33, which is the 13th term. And solving for the third term, we get the third term is equal to 3. So we know the third term, we know the 13th term. It should be easy to find yung common difference by using the arithmetic sequence formula. And 13th term is equal to the third term plus 13 minus 3 times d. Substituting the terms that we know, 33 is equal to 3 plus 10d, or d is equal to 3. And this is our common difference and our final answer. So that's the basic idea of the arithmetic series, specifically the partial sum of an arithmetic sequence. Prepare natin yung first yung last terms kasi yung sum nila ay pareho lang dun sa sum ng second and second to the last, third and third to the last, and so on. And we just multiply it by the number of pairs. So I hope nakuha natin yung same insights na nakuha ni Carl Friedrich Gauss. And I'll see you sa next lesson natin on the next type of series.